this is Mrs. Tempest, and today I'm going to go through some more density calculations, bringing in a little bit more of what we did in the gizmo when we were doing unit conversions and significant figures. So today our target is to use dimensional analysis to calculate density or use density in a calculation. And I'm going to warn you that this is going to be a lot different than what you've seen in math class. So overall, we're going to end up with the same answer that you'd probably get in math class, but we are also going to take into account canceling out units and using significant figures. All right, so dimensional analysis is used to show conversions from one unit to another. This can be set up using fractions or in a grid, and we're going to use the grid more than we would use the fractions. We're going to use conversion factors to convert from one unit to another. So an example of a conversion factor would be 1 kilogram, that is not right, is equal to 1,000 grams. I don't know what I was thinking. And then in calculations, we can flip a conversion factors to cancel out units. So as you guys should have seen in that gizmo that we used, you had the ability to flip one of those conversion tiles, they called them, in order to find your answer. So we are going to practice with this today. So we're going to start off with a pretty easy example. So generally when we approach metric conversions, we said that we were kind of going to use the bubbles and that chart that we had. The ladder chart, but today I'm going to show you how to do it with dimensional analysis. So anytime that we're given a word problem, you're always going to be given a given, which is going to be the number that's given to you in the problem. So this is going to be my given for this problem. And then you're going to have a wanted, or what you are trying to solve for. So in this case, it says how many kilograms, and this is what I'm going to be solving for. So this would be my wanted unit. So we need to look at our wanted and our given and figure out a conversion factor. So as I showed you in the last slide, slash corrected for you, we know that in 1 kilogram, there is going to be 1,000 grams. All right, and we're going to use this conversion factor in our dimensional analysis grid. So with dimensional analysis, I'm always going to start with my given up here. So I'm going to put my 5,430 grams up in this corner. And then I'm going to make a grid. So when I make a grid, I'm going to just keep that 5,430 grams, my given, in this upper left corner. And then I'm going to use this conversion factor, which is probably similar to what you guys saw in your gizmo. I'm going to use that to cancel out grams and find kilograms. So if I have to use either the 1 kilogram or the 1,000 grams, I know that these are going to be equal to each other, which means that one has to go on the top in the second column and one has to go on the bottom. Now, if I want to cancel out grams, I would have to make sure that I have the same unit in the numerator and the denominator. So if I have grams up here for my given, I'm going to make sure that I'm going to have grams on the bottom so that it cancels. So using this conversion factor, I would put my 1,000 grams on the bottom and I would put my 1 kilogram at the top. All right, so if you remember when we first talked about significant figures, you guys learned about counting numbers or not defined numbers. And this would be an example, since it's a conversion factor, it would be an example of one of those not measured precisely numbers. So when we're doing significant figures, this part really doesn't count. The thing that counts is going to be my given. So if I want to count significant figures for this number here, I would determine if there is a decimal. So I do not have a decimal in this example. So that means that that trailing zero will not count. And I have 1, 2, 3 significant figures. So when I type this into the calculator, it's not going to be an issue when we're doing metric conversions. When you typed this into a calculator and you took 5,430 divided by 1,000, your calculator would have given you 5.43 which it has three significant figures, so we don't really have to worry about rounding that one. Now, my grams canceled, remember, and the unit that I'm going to be left with is kilograms. And then I just want to do a double check. So what I usually do is seeing, okay, the unit that I am trying to solve for, which is kilograms, is left here. I can't cancel it out. That's the unit that I would have in my answer. So that's just kind of our double check to make sure that we solved this problem correctly. And then I always like to put a box around my final answer just because it makes it very clear to myself and to whoever is looking at my paper what the answer is. So if I'm going back and I'm reviewing, it's really easy to see basically how I got the answer. Okay, so when we're talking about density, one thing that you should recall from the last density calculations video that you saw is that the unit is going to be grams per milliliter or grams per centimeter cubed. So grams per milliliter, so the milliliter part, that is going to be if you have liquids, whereas the centimeters cubed would be if you have a solid. So these are really going to be equal to each other. So 1 milliliter is generally going to be equal to 1 centimeter cubed. So what that really tells us is how many grams there are per 1 milliliter or per 1 centimeter cubed. So when using a given density in a calculation, we can think of it as a conversion factor. My example is the density of water. So the density of water is 1.00 grams per milliliter. And I can use that as a conversion factor because I know that that's really telling me that I have 1.00 grams for every 1 milliliter. Now the grams part, this is technically going to be a measured amount. So when I'm thinking in terms of significant figures, this actually does count. And here it would be 3 significant figures because we do have a decimal, so those trailing zeros count. So let's try using this in an actual calculation. So my example is, what is the density of ethanol if 25.0 milliliters has a mass of 19.73 grams? All right, so anytime that we're doing a density calculation, you should remember that density equation. So density is equal to mass over volume. Now, when I'm looking at a word problem, one thing that I do like to do is underline what is given to me in the problem, numbers-wise or measurement-wise. So I know that 25.0 milliliters, so milliliters, goes with the volume. So I'm going to just label it a V for volume. And then the 19.73 grams, grams is the unit for mass. So I know that this is mass. And then it's asking what is the density. So this is what I'm going to try to solve for. Now with this problem, I don't have any fractions here, and I don't have anything that I can turn into a conversion factor. So I'm going to set it up just like you probably normally would in math class. So D is equal to M all over V. That's my original equation. It is nice to actually have that equation before you start punching in numbers. All right, and then if I'm going to put in the numbers now, my mass would go on the top, so 19.73 grams on top. And then my volume just goes on the bottom. So this probably is really similar to math. I'm not sure if they have you put in the units when you're doing it, but I know that density's unit is going to be grams per milliliter, so I don't have to worry about canceling anything out. And basically, I'm just going to take those numbers and I'm going to type them into my calculator. And when you type this into your calculator is going to give you 0.789 and then I'm going to just double check my significant figures. So I have two givens in this problem. I have the 19.73 and the 25.0. Now remember that when we're doing division or multiplication, we have to go with the least amount of sig figs. So in my 19.73, this would actually be 4 sig figs, whereas my 25.0 would be 3 sig figs. So even though my calculator gave me an answer of 4 sig figs, so 7, 8, 9, 2 are all significant, I have to round this to 3 significant figures. And remember that when we do that, we're always going to come in from the left and start with our first non-zero number. So here's my first non-zero, 1, 2, 3. So this thousands place has to be my last significant digit. And since it's a 2 after that 9, I'm just going to leave it. So I would round this to 3 significant figures, and I would report my answer as 0.789. So that's 3 sig figs now. And then I would make sure that I put on my units. So neither one of these units canceled. So it's going to be grams per milliliters. And then I would put a box around it just to make it really stand out. All right, this one's a little trickier. This time they're telling us that the density of gold is 19.3 grams per centimeter cubed. And you find a nugget with a mass of 253 grams, and you need to figure out what the volume is. So I am solving for volume, so this is going to be my question mark. I'm given that I have this mass, and I have a density of 19.3 grams per centimeter cubed. Now, what this really is telling us is that for gold, 19.3 grams is going to take up 1 centimeter cubed of space. So I can actually turn that into a conversion factor that I would use in my dimensional analysis. So this time I'm solving for volume. So our original equation with density was D equals M over V. But if I have to solve for volume, you can do it 2 ways. So you can either multiply both sides by V, and then that cancels out on the right. And then I still have to get V by itself, so I would divide both sides by D. So I could say, let's see, this one cancels out. Volume is equal to mass over density. Or I could think about it the shortcut way. So you were given this triangle in your notes. So this is D and V. All right, so basically what I'm going to do is cover up the one that I'm solving for. So if I cover this up, I know that V is going to be equal to M over D, or mass over density. You get the same answer either way. If you're really good at just manipulating equations, you might want to do it the first way. If you just want to do it a really quick way, you're going to just cover it up and then write your equation out. Either way, I do want to see this manipulated equation. So this is called a variable equation. And you should, as I said before, you should always get in the habit of writing the equation before you actually put in the numbers. So here's my manipulated or variable equation. Now I can punch in my numbers. Now with this one, density is going to have a conversion factor. So I'm going to use my grid. And generally, I like to put density, since it is the one that has a conversion factor, as my second column. So if I'm going to have 2 columns, this one's going to be for mass, this one will be for density. All right, mass is in the numerator here, so I'm going to put my given mass in the numerator. And then density, the main part of the density, the 19.3 grams, is going to be in the denominator as we see here. So in this second column, I'm going to put that part in the denominator. Or you can look at it like, okay, I have this conversion factor. I have grams here for my mass. I need to cancel out grams. So if I have to determine which part goes on top, with my conversion factor, which part goes on top, which one goes on bottom, I'm going to know that this will go on the bottom, and then the 1 centimeter cubed would go on the top. All right, so now if I look at this, I have it set up in dimensional analysis. My grams would cancel, and I'm going to be left with centimeters cubed, which is great because I'm solving for volume, and that is how I'm going to measure volume. So if I type this into my calculator, you would put 253 divided by 19.3, and when you do that, your calculator is going to give you an answer of 13.1088. But you know that you're smarter than your calculator, so what you're going to do is count up sig figs for both of our measured amounts, and then you're going to round to the correct significant figures. So with the mass, we have 3 sig figs, and then with the density, the measured part, it's going to be 3 sig figs as well. I need to round this to 3 significant figures, so it would be 13.1 centimeters cubed, and that's how I would report my answer. And the reason, I know it seems a little bit difficult or not what you're used to, but we're going to be using this throughout the rest of the year. And I really want us to start getting in the habit of showing how our units cancel. All right. And it'll just make when we get into doing moles and stoichiometry a lot easier. So when you guys are practicing this, make sure you are setting it up correctly with dimensional analysis if needed. So if you're solving just for density, generally you don't need to use dimensional analysis. But when you are setting it up where you're solving for volume or for mass, you will be using dimensional analysis. So make sure that you set it up correctly on your worksheets. All of my answer key for density problem 1 has it set up that way. So when you guys are correcting as a group and talking about it, make sure that you are paying really close attention to how I set things up. So all of these things, the variable equation, if needed, the dimensional analysis, and then rounding to the correct sig figs, that's all going to be part of getting a 4 on a summative assessment. So make sure that you get in the habit of doing these things, and please send me an email if you have any questions at all.